All right, Ron, really great stuff. I know a lot of people are waiting for this session, so the floor is all yours. Anything you want to say before we get into it?
No, let's dive in.
Let's go.
All right, great. So hi, everyone. Hope you have an interesting day. So I'm Ron Kimchi, co-founder and CTO at Eon. Prior to my time at Eon, I worked for AWS. I was the general manager for the migration and disaster recovery services. So seen a lot of customers doing disaster recovery and backup from up close. So a few words about Eon. We're a cloud infrastructure, cloud backup company. We're backing up your entire infrastructure, the various data sources, and of course, DynamoDB as well, which is our focus for today. So just a quick recap. As you all know, DynamoDB is just going wild. We're seeing it with all of our customers moving more and more of their data sources into DynamoDB. Obviously, for the performance, the scalability, all the simplicity and the reliability. But the scale for the space of backup introduces a new challenge or a new problem coming from this space where things were kind of bounded in a disk that has a finite size. When we look at those DynamoDB tables, and for the large customers that are starting to scale them more and more and more, the challenges of backup, and especially recovery, which is the most important piece in backup, are extremely amplified when we get into this scale. So, as always, we have our shared responsibility model. So it's really important for customers to know what's their responsibility and what is AWS's responsibility in terms of protecting your data. So focusing on DynamoDB, as well as other services, it's pretty much the same thing. So you have the cloud provider, which gives you your SLAs for data durability, availability, etc. But it's up for the customer to apply and to meet their compliance requirements, their business requirements in terms of backing up their data and recovery based on the customer's requirement. So DynamoDB, as well as any other data source, your RDSs, your EC2s, etc., your S3s, will not come built in with a backup configuration applied. Customers are responsible to apply the applicable solutions in order to meet their own requirements. So we'll talk about how do we do that and how do we do it in scale, more importantly. So let's talk about that data durability. Durability is an extremely important point when we're talking about storage in general. It basically says what the storage itself is committed to in terms of data corruption in the storage layer itself. So as you know, EBS volumes have different data durability per volume type. S3 has an outstanding data durability of and so on. But data durability doesn't mean that data cannot be corrupted. Data can still be corrupted either by malicious actors or by human error. If someone would delete data through an API, the data will be deleted. If someone would push corrupted data into any data source, it will still be corrupted regardless of the durability of the storage layer itself. So durability is outstanding with DynamoDB, yet we need to protect ourselves from human error and malicious actors. When we look into continuous protection, PITR, point-in-time recovery, once again, something that we see with the various databases. So we have that as well with DynamoDB, as well as the option to extract data, export data out of DynamoDB on demand. But what are the actual challenges when we, especially those are amplified for enterprises or for large cloud users, for resilience when you start to hit that scale? And that's what we've been seeing throughout the years. And once again, amplified once we got to those scalable managed services, which are not bound to a volume or an instance or to a finite set of EBS volumes attached to an EC2 instance, whether it's a managed database or self-hosted. So let's talk about these challenges a little bit. So first of all, what are customers' requirements in terms of data retention? These are driven by either regulation, compliance requirements, or internal business needs of each individual customer. What we usually see is that when customers define or describe their requirements, they usually talk about the data itself, the characteristics of the data, as opposed to the infrastructure. So usually customers would not say, my DynamoDB needs that retention and my RDS, for example, needs a different retention. They would usually say that my financial information that is running in production would need longer retention versus our non-PII data, which doesn't have any customer data or potentially non-prod systems. So customers are always defining the requirements, or usually defining the requirements based on the data that they store in those various data sources. Exactly the same thing for DynamoDB. And for many cases, they require longer retention. Cross-region or multi-region recovery is also driven by most compliance programs today. So customers need to know how they can recover their data. And one very important note about data recovery. The word recovery got a whole new meaning in these types of services. And instead of just looking at it in a binary way, can I recover my data or not, meaning build a full DynamoDB table in a different region, customers today actually need to access their data rather than build the entire data set in a different region potentially. So backing up the data in a way that allows customers to access the data, especially when we go into the large tables. We've seen customers with trillions of items in DynamoDB tables. And in order to prove that they're backing up their data for compliance purposes, audits, and so on, they don't want to recover the entire thing. They want to prove that they can access the backed up data. That's a very important thing, which is amplified tremendously when we're looking at those scalable data stores as DynamoDB. And also the number of resources. Setting up and managing thousands of tables across multiple accounts is extremely difficult when, once again, customers need to apply backup policies based on their actual data and use case and not just the service type. So a little bit about granular restore. Granular restore basically means that I can pluck a few items from a backup, whether it's a backup of a relational database, of a DynamoDB table, or of an S3 bucket, or a VM. Customers need to either for full recovery use cases, let's say that someone have corrupted, deleted, updated specific records or items, and now they just want to take a few items out of millions or billions or trillions, as we've seen. Doing a full-blown recovery would result in losing a lot of data. So what we've seen customers opt for going in those larger data sets is allowing the customer to recover just a subset, a very small subset potentially of the data itself. Cost is always a challenge when we're talking about backups that require long retention. So customers want to be more efficient so they can spend their money on other services that bring them value, like AI, and etc. And also ransomware and malicious actors. Protection against those is extremely important, something that is very widely in use and applied when we're looking at more traditional infrastructure or services. So customers apply ransomware protection for EC2s, that's almost table stakes for the storage services and even self-hosted databases. But when it comes to the, let's say, more modern managed services as DynamoDB, they lack short, and we've seen that this was a huge requirement of an existing risk that customers have come to us at Eon to provide solutions and ransomware detection and protection for DynamoDB. This is a huge challenge today. So a few words about Eon and how we've tackled those challenges in order to provide as a partner to AWS these solutions for DynamoDB customers with a focus of backup. So first thing is a centralized control. It basically means that customers will be able to apply their business requirements over their infrastructure at the organization or the organization unit level. So something like protect or backup my financial information, my PII in production or whatnot, in the specific retention in a specific region. That is something that customers can apply with Eon, and that is completely tag-free. The biggest challenge here today is that customers need to manually tag each individual table, which when we talk about the thousands of tables, it's extremely difficult to a centralized backup team. With Eon, they can define this simple rule, and Eon does the data classification automatically. We'll see that in the demo. That yields for basically smarter retention that is based on this classification. Obviously, when tags are applied, Eon can use tags as well. For cross-region and account coverage, basically, we've seen that those long retention cross-region backup requirements kind of have some gaps in them, in the native solutions, both cost, doing incremental only always. Incremental basically means that if a subset of the table have changed between one point and another, let's say that we're doing a daily backup or every 15 or 30 minutes, it doesn't matter. We only want to take the subset that have changed, and that the difference between one snapshot to the other will only be the delta. Otherwise, the backup storage starts to get inflated. And we've seen customers that the storage that they're paying for the backup cost them more than what they're paying to the actual production workload, which obviously doesn't make any sense for customers. So doing that incrementally and doing that at scale. Let's talk a little bit about recovery of the data. So what is granular restore and queryable backups? Basically, what Eon does when we're backing up a DynamoDB, first of all, once after we do the first heavy lift, we will listen on streams and only pick up the updates on an ongoing basis. So this is very efficient. It means that when you're writing new data to a very large table, only the new data that is either written or updated or capturing deletes, only these are being transitioned into the backup, a form of CDC, the terminology of backups. But so what's even more interesting is that the backup itself, which still sits on S3 as all backups, EBS snapshots, RDS snapshots, all of those, and for DynamoDBs, under the hood, all sits on S3, because that's the service with the sufficient data durability for backups. We do the same with Eon, but the format is different. We're converting the backups into a readable format, into a Parquet, incremental Parquet files. Once we're doing that, we're also doing global deduplication of the data, meaning still only per customer in your account. But when we do see a lot of repetitions or duplications in the data, we basically compress it in a larger scale. That cuts down cost drastically. But now comes even the best part. It basically means that the backup is basically transformed into one huge data lake, still immutable, still object locked, air-gapped, full-blown backup. You can't delete it, you can't write it, you can't override it, but you can query it. So using an engine like Athena, for example, allows you to query the backup as if it was live at any different point in time. Obviously, you can also restore the entire thing to a fresh DynamoDB table, cross-region, cross-account. These are very important. But the fact that the backup itself is queryable basically means that on one hand, you can enjoy the amazing performance of DynamoDB in your production. and scale it out as much as you want. So we've seen customers, once again, with trillions or hundreds of billions of items in tables. And when an auditor comes in or there's a local data corruption event, they don't need to restore the entire thing, which accrues a lot of cost in WCUs, just writing trillions of items all over again, only in order to pluck a few out. And also time. That can take hours or even days, depending on the pace of writes that you provision. So with that, the backup is always live. And customers can just run a query directly on top of the backup with any engine that supports Parquet files. It can be EMR, it can be other service, once again, Athena and others, and just pass an audit in a breeze. On top of that, as we've said, ransomware protection is extremely important. Ion does that. We calculate entropy of those items on backup. And when we see that if something changes, if someone tries to encrypt your data, even if they don't obtain access to the actual storage because it's a managed service, they can still, in the application layer, encrypt your data. Read an item, encrypt it, and write it again. And Ion will detect that, push in an alert, and allow you to recover from a clean point in time, exactly as we do for block devices and object storage. And last but not least, continuous posture, what we call CBPM, Cloud Backup Posture Management. We've kind of borrowed that term from the cloud security space, where centralized teams required control, just identifying whether is everything meeting their compliance requirements. So visibility, dashboards, and a centralized location where customers can see how is their DynamoDB backed up, based, once again, on the data itself and not just tags, resource IDs, etc. So a few words about the architecture. So basically what Ion does is we are plugging in into the customer source account. APIs only. Customers own their IAM policies that they grant to Ion, either by running a CloudFormation stack or other means such as Terraform. And Ion, fully agentless with APIs, starts by capturing the initial data into a dedicated single-tenant account where data is being processed and scanned, doing data classification, identifying personally identifiable information, PII, PHI, patient health information, financial information, and so on. And from that point on, we're converting the data into a Parquet file, which sits in the Ion air-gapped vault in S3. Customers can control the KMS as well. And from there on, listening into streams and managing deltas. When customers want to restore data, they can restore data into their account, either doing full table restore, or once again, just run their Athena or EMR directly on top of the vault. Scale is everything here. Building a backup solution for trillions of items is where we've seen customers basically fail meeting their audits. Recovery of a full-blown 2 trillion item just takes too long, it's too costly. And we've seen customers that have been struggling with that. And while their production DynamoDB was working in an outstanding way in that scale, their backup fell short. And once again, with Ion, the fact that they could query the backup within seconds, couple of seconds out of those 2 trillion items, they could get their queries out, prove to their auditors they are backing up the data, that they're meeting their retention policies, and that was a huge win. And let's see the product in action. So I'll stop my share and show you the product.
And if anyone has any questions at any time, make sure to drop it in. We'll begin to the Q&A as soon as the demo is done.
Perfect. So this is the Ion console. Basically, what we see here is data that is backed up from a single inventory view from different multiple cloud providers, resource types, and so on. You can see a DynamoDB table here in that example. And what Ion does is basically starting with that data classification, fully automatic. If I'll zoom in into a specific table or resource, I can see here that first of all, I have this data classes section here, and I can see that we've found some PII, the exact entities that were detected, and their location. And from here, customers can apply the relevant backup policies. So in this example, you can see that this resource was backed up because the customer have defined that a simple rule, completely tag-free, that everything that is running in production and either has financial information or PII will get a specific backup policy. In this case, a daily backup for a day for 9 days, in one vault, in one region, and a monthly for in another. We can go down to very granular, what we call RPO, recovery point objectives. So backing up every 15 minutes or 5 minutes and so on. But what's really interesting here is that the customer, note the rule here. It didn't say DynamoDB in any way. It doesn't require any tags. It's not relying on tags or specific resource IDs and so on. You can generate very complex rules, but also these very simple ones. And what's great here is that if a customer defines that rule, let's say that they're now modernizing data and they're in their journey, they've moved a Postgres database from EC2 to RDS. And then they've decided to modernize it even further and moved it into DynamoDB. If their policy would have been based on tags, those tags would get lost in each of those steps. But because Ion classifies the data itself, once the data moves from one service to another, the backup policy is applied automatically. So compliance is not broken. Same for, obviously, for new applications. When customers spin up new applications, new DynamoDB tables, the backup, if they're running in production and they have financial information or PII, this backup policy will stick, and this can go into very flexible ones. A few words about recovery. Obviously, customers can select any point in time, as we've said, and recover the entire thing. They can select the target account on the fly, and from here they can go on and set their WCUs, the write capacity units, and restore the entire table. But as we've said, what's even more interesting is when customers need to just access a subset of the data. So let's look at our database explorer. I'll zoom right in. And here, customers can use, this is the Ion console, the Ion GUI, but under the hood, it just runs Athena in the customer's account. So here you can see that we can select any point in time, select that, and from here on, I can run any SQL query. So let's pull a few records. I'll leave the results here. And I'll give it a run. So now this goes and queries the backups directly. It did not restore the backup into another DynamoDB table. You can see here the JSON representation, but we do schema inference, so we can flatten it out into a tabular view. And the actual results are dumped into an S3 buckets and customers in their customer's account. So you can potentially do that for millions or billions of rows. That simplifies the recovery process tremendously. The other challenge that we've seen customers face is just searching their data. Where is my backup? When an auditor comes in or if there's a data corruption event, you need to, first of all, search for your data, potentially in an enterprise or environment with hundreds of thousands of resources or hundreds of thousands of or millions of backups, snapshots, and so on. So We do that for files as well, but here we look at tables. Let's search for claims. In this example, it will search across all of the different tables. In this example, it found some. This is an RDS. It can be a DynamoDB table. It can be other data sources as well. So searching for the data, we index all of the data on backup, so customers can search for it and then run their SQL queries directly on top of the backup, summarizing again, as well as just doing a full-blown restoration when needed. All right. So what's next? So first of all, 3 actions. If we look at what can you actually apply right now, is first of all, you can automate your backups, which is very, very important just to get that level of visibility. Even more importantly, make your backup usable. Think about it, basically transforming your DynamoDB, all of your different DynamoDB tables, into one data lake, which also holds your backups from your RDSs, from your Redshift, from all of the different data sources, your self-hosted databases under EKS or EC2 or whatnot, into one huge usable data lake. Does not only solve the challenges of data recovery, it also allows you to run analytics on top of it across space, across different resources. So you can join data across different resources, but also across time, because all of the points in time are basically stored in that one big data lake. So customers can also find some trends across time, over time, which is very interesting. It also very simplifies testing, validating recovery, ransomware protection, as we've described as well. So through the AWS Marketplace, you can just very easily give it a go. And we're seeing that the customers are very happy about it, especially doing all of that, removing that heavy lifting of just chasing your tail in order to apply your backup policies for this so ever-changing environment. So great to see how we can simplify that as well. And the results speak for themselves. Lower cost, you'll see in your backups at least 50% cost reduction for DynamoDB backups, as well as simplify the recovery process. So the project is practically 100% self-funding. You don't need to get a dedicated budget while you're simplifying backups on one hand, simplifying recovery, as well as reducing your ongoing costs. So basically data classification and all of that, you get that for free. So thank you very much. And we're up for the Q&A.
Great stuff, Ron. All right. A lot of people have been asking for this. All right. So we have a bunch of questions. Let's go to the first one in the queue. They want to know, what do we mean by it does data calculations automatically? Can you please elaborate a bit?
Yeah, absolutely. So if we would steer away to a different line of products that are called DSPM, Data Security Posture Management Tools, there are a few leading vendors in that space. We've seen that data security had a very similar problem as data protection or backup. And that's, I have so many different resources out there. And what is the actual data that we have in each of those tables? What Eon actually does is sampling that data, and we run data classification algorithms on top of it that identify whether something has financial information, PII, and so on. There are various techniques. This is not a new domain. Usually there are a mix or a mixture of arithmetical calculations, regular expressions, etc., and obviously using LLMs for that. So once again, using Bedrock, which is an outstanding service, in order to get deeper level of data classification that we're seeing amazing results today. The result is automatic tagging of those resources. So we're augmenting the inventory with the data classes that were identified automatically, when we're backing up the data. The biggest advantage of a backup system for doing data classification is that in order to back up data, we need to process or read 100% of the data anyway. When we read the data, we're also doing these calculations.
Great. All right. Ransom-ready resilience. Is that anomaly detection, or do you provide capabilities like hunting for any threats in the environment causing custom Yara rules or file hashes? Can we quarantine bad backups?
Yeah, it's a great question. So absolutely. I'll talk about ransomware detection and protection in general, and we follow the NIST guidelines on that space. And the unique thing is that we also apply it for those managed databases. The only solution out there that can do that for DynamoDB. Ion is the only vendor that can do that. And when we talk about ransomware protection as a whole, it's combined out of a few steps. First of all, you need to detect ransomware, and that's by calculating entropy. That is basically a measure of how random the data is. And when we see that the entropy changes and the data looks more random than it was and passes a few thresholds, we flag out those backups. We quarantine them, but not only quarantine them, we're making sure that the latest clean version of the data or the latest clean snapshot is never deleted. But now think about the power of granular restore in that sense, because we flag it not at the resource level, but at each individual item. We scan all of the data for the backup, and we calculate those entropy and those anomaly detection algorithms on all of the processed data. So we know it by the item. With that granular restore capability, let's say that only 3% of your data was encrypted maliciously. And you need to recover that from a specific point in time. Obviously, and you detect that 2 days after the event, obviously you can restore the entire table into the latest clean snapshot, which is in this case 2 days old. But with Ion, you can also recover only if there is no hard dependencies between items. You can recover only the subset that was actually impacted and encrypted, minimizing data loss drastically. Support that for files as well, but it's very interesting in these use cases.
Excellent. Another security type question. For security reasons, the data cannot leave our environment. So it looks like Ion cannot support this today. Is that correct, or is that on the roadmap?
No. Ion supports today two deployment models. One is when the vault and the scanning account, which process and store the data, is provisioned by Ion. We did see customers that opt to do that because of doing virtually air gapping, especially against identity theft threats and etc. But we also support a model where the data is stored in the customer's account, never leave the customer's account, and both the scanning and the vault sits in the customer's account. All the functionality is still supported. So we do support both models today.
Great. Okay. Christian had a question. He wanted to know, can I think of the Ion platform as effectively turning my backups into a secure queryable data lake that I can use for analytics and also for AI use cases rather than the traditional black box AWS backups?
Absolutely. Spot on. So in general, that's the idea. That's what we've seen. If we'll go back to the day where we've decided to start Ion, it basically started and was driven by the fact that snapshots were outdated. It is built in general, not for a specific service, for all services by all cloud providers. The snapshots were basically built in the form of storage, but snapshotting mechanisms were kind of outdated, and the data could not be used. So it's a snapshot is basically storage that sits under the hood on S3. Customers are paying it per gig per month, like any other storage service, but they can't read it. If they need to access the data in an RDS snapshot, for example, they need to do a full-blown recovery process, which basically means copy the data to another location, that required networking, compute, and so on in order to access the backup, while you were paying for that storage that you cannot access. In addition to that, we've seen that customers have petabytes of data in their snapshots, but they can't leverage it for AI, for analytics, and so on. So with Eon, our goal was to, first of all, make it more efficient, cost efficient, and so on, make it automatic and easy, but primarily to take all of that storage that can go up to hundreds of petabytes for customers. And while customers are paying for that storage, allowing them to use it for other purposes, AI, analytics, as well as simplifying recovery.
Very cool. All right. Can you describe Eon's architecture for high availability? Would Eon be available when a region goes down, similar to what happened a few weeks ago?
Yes, absolutely. So basically, Eon has a control plane, which is a very thin control plane. Customer data does not go to that control plane, and it's a multi-region control plane located in multiple regions. So it is fully resilient to outages or to whether there are obviously zonal, but also regional.
Okay, great. Very nice. How does Eon determine when production versus non-production? Because it was mentioned 2 to 3 times that Eon doesn't use tags, so that's really big and helpful.
Yeah, absolutely. Great question. So it is relatively similar to what we're doing with data classification, meaning that we're leveraging various set of techniques. But as opposed to data classification, when we look at the environment, we analyze multiple sources. We're basically clustering a set of different set of resources into groups by analyzing access logs, topology, and so on, in order to identify which systems are basically composed by the various resources. We also look at the other details, access logs, tags as well. Tags and names are important, and they are used as an input as well, and automatically outputting the environment. Customers can also apply custom rules for data classification and the environment mapping.
Great. You mentioned that your product allows access and data for backups. Can we run analytics across different tables and resources?
Yes, absolutely. When we backing up the data, it really doesn't matter. It is a lot of IP and work that we had to do in order to support the different data sources. But once we support Postgres, for example, it doesn't matter if that Postgres was coming or hosted in an RDS, EKS, EC2, or whatnot. When we back up the data, we convert it into that bucket format. When we back up DynamoDB, we do the same. So now customers can, at the backup, can basically run any analytics engine. So Athena is basically an example, or EMR, but they can run it across the data lake, and that allows them to join data that came from that Postgres backup in this example with the backup of that DynamoDB table, as well as a CSV, for example, that was stored on a VM on an EC2 or pulled from an S3 backup.
All right, we have time for one last question. Will wants to know, does selecting any point in time result in waiting for the data to be hydrated to be made available?
No. So selecting a point in time, I'll be more specific. When we talk about recovery, we have 2 options with Eon. One is doing a full-blown recovery of the entire table. You select a point in time. You need to wait till that table is fully hydrated. But if you want to access the data, you can select any point in time and just run your query directly on top of the backup on that point in time. So there is no hydration at all.
Excellent. Well, thanks again, Ron, and thank you, Eon, for putting this together. Any parting words of wisdom for DynamoDB Day before we go?
So just amazing to after spending many years at AWS and starting as a GM of on-prem to cloud VM to EC2 migration. It's amazing to see how customers have adapted to use these services over past 7 years, and the adoption goes wild. So an amazing service.
Absolutely. Awesome. Well, thanks again, man. I really appreciate it. And thank you for putting this together. Thank you so much. Cheers.
Thank you so much.
Thanks.